How many of you are having to access Tegrity at all? Any of you having to do that? Look at my Tegrity lectures. Are you using that? How many of you have seen the other videos that I've posted in Blackboard? There's a button that says Related Videos. Now, if you're not doing that, that's your prerogative. But I have taken the time, when I'm covering a specific topic, to find something on YouTube or somewhere that I think is Khan Academy, PatrickJMT.com. All those they have all their videos on YouTube also. So it's easy for me to get the video off YouTube and just embed it in the Blackboard. So that's what I'm doing. And if I've taken the time to pull that, if it's a topic you're having trouble with, then I think I would take the 6 or 7 minutes that the video is just to see if they can explain it better than me. Okay? Maybe you needed somebody else's perspective and not just mine. So I'll pull anything I think is good, I'll pull and put it in your Blackboard shell. All right, so to start off tonight, we're going to review. See where we're at. So pretty much you just have 4 types of differential equations that you're supposed to be able to know how to solve. Separable. So let's do one. We did one already with separable. Here's another one. That means I should be able to separate the variables out. If you get a problem on the test that's separable and you have a y prime in there, what are you going to substitute in for y prime? dy over dx. You want to substitute that. That helps you in your separation. If you get y prime in your original problem, substitute dy over dx. So I'm going to multiply dx on both sides of this equation. Okay, everything is not good here. So I need on the right side to get rid of that y. So I'm going to divide both sides by y. And on the left side, we don't need that x squared plus 4 quantity. I'm going to divide that off both sides also. It'll leave me with 1 over y dy. And x over x squared plus 4 dx. Integrate both sides. What is the antiderivative of 1 over y? Okay, and I'm going to be lazy and not do absolute value, which y'all get you're supposed to, really, right? Okay, on this one, x over x squared plus 4. Is that going to be tangent inverse? Or is it going to be u substitution? Because you got the x on top. By the way, I have more than just 1 or 2 students doing that wrong. Whenever you've got x squared plus 4, if that was a 1 on top and it was tangent inverse, the pattern says 1 over a tangent inverse of u over a. And I got people putting 1 over u tangent inverse of a over u. They're getting those two things switch swapped. You got it circled on your test paper if you did that. A is always going to be the square root of the constant. So in this case, it would be 2. And the x, the u squared, would be x in this problem. Of course, this is not tangent inverse, but if it was, I'm just saying, y'all are getting that reverse on how you do it. So be careful with that. The a represents the number, the constant. In this case, your u would be your x squared plus 4. du is 2x dx. So I need a 1/2 compensation. 1/2 natural log of u plus c. Okay, what can I do here? That wouldn't help me much. With the fact that ln is on both sides, what can you do? E it. Okay, so this is some good algebra right here. Be real careful. So that's going to leave you y equal to, what is that 1/2 actually? It's an exponent. When a number's been pulled in front of an ln, it's an exponent. So that's what's the 1/2 power the same thing as? Square root. And then the e to the c, what happens there? Constant 1. So constant 1 on the square root of x squared plus 4. And guess what? That's it. I don't have my notes out here. Let me check myself, make sure thank you. Okay, so x's you're going to leave alone. Y's you're going to make your substitution. So x squared minus y squared would be x squared v squared. Dx plus 3x times y, so that's xv, times dy, which is x dv plus v dx equal to 0. Do a little algebra here. It will be x squared dx minus x squared v squared dx. Okay? Plus, this would be 3x squared v times, I'm going to distribute that. So all this times that in distributive property. So that would be 3x cubed v dv plus 3x squared v squared dx equal to 0. Any algebra, anything I can combine here? X squared v squared dx. You could just take that 1 away, so that would be 2, right? So I'm going to do 3x cubed v dv. Keep that on the left side. All the dx stuff we're going to move to the other. So it'll be minus x, let's see here, minus x squared if these two terms can combine, you got minus 1 plus 3. So I'll be minus 2 x squared v squared dx. Okay? And that could probably be cleaned up a little bit better. This one looks pretty bad. How can I factor that right side, guys? Can I do a negative also? Negative x squared. And that would leave me 1 plus 2v squared dx, right? Yeah. Okay. So in separation, I need to get rid of the x cubed and the 1 plus 2v squared. So I've got 3v over 1 plus 2v squared dv equal to negative 1 over x dx. Good. Making sure I got some space. Don't throw your hands up in the air and quit, right? Because we can do this. Any ideas on this first one? The 3 is just a stinking constant I can pull out front. So what about u substitution? Would that work? On the left side, u would be what? Then du would just be 4v dv. So I've got the v dv. I need to compensate with the 4. So it'll be 1/4. 3 times 1/4 will be 3/4. And that would be the integral of 1 over u. So natural log of u, 3/4 natural log of 1 plus 2v squared, that's your integral on the left side, equal to what? No, it does not. I actually prefer it on the right. That's just going to be that's my way of doing it every time. Okay. Next page. Let me rewrite this. What was it? 1 plus 2v squared? Any suggestions? When it's plus, you can add those, you can multiply those together, right? Could I have done E on that step right there? Yeah. But what he said is not wrong, so I'm going to continue with what he said. He's wrote it as one logarithm. Now can I E it? Do the E thing on both sides? So I'm just going to have x times 1 plus 2v squared to the 3/4 equal to c sub 1. It's a nasty problem. That could possibly be good. Right here. We would get the same stuff eventually. Okay. Y'all care if we backtrack? Nobody said anything wrong. Please understand that nobody's done anything wrong yet. He's just giving me a different idea. Multiply through by 4. C still C, right? Then E it, you said? One plus 2v squared to the third equal to right? You see how I got that? E to the c will be your big C with x to the negative 4th power. Multiply both sides by x to the 4th. Okay, now this is, we can do that if y'all don't like that negative exponent there, which I don't like the negative exponent in there. And I think that might be better than having a 4/3 power in there. It might be a little bit cleaner than what you had. Okay, What step are we forgetting about? We haven't forgotten about it, or we just maybe hadn't got to it yet. What do you put back in? V. What do we put in for V? Y over X. Two y squared over x squared. And I can't distribute, can I? You can't distribute that x to the fourth to this because this is all to the third power. I think we're pretty much there, folks. Yeah. Well, shoot, that's good enough. Yeah. And I would have to definitely, on a problem that hard, look at your work, see that you hadn't done anything wrong. Now, one thing I could do algebraically on this if I wanted to, inside the parentheses, could I get a common denominator there? Inside the parentheses? Looking at me like, oh my God, is he serious? So what would 1 be the same thing as? X squared over x squared, right? So let's see here, x squared plus 2y squared over x squared cubed. If I cube it, I get x to the fourth times x squared plus 2y squared cubed over what? X to the sixth. Can I do anything in algebra now? Leave me with 2. So this is what I've got down for my answer. On my sheet that I did like 8 years ago, y'all see where I got that? Here's the rule of thumb. If your algebra stinks, you're better off just stopping than keeping on and on and on doing something where you're going to make some of the mistakes, you're going to make the whole thing. That's not a good problem first time. It's not a clean problem at all. But man, I could keep on going with it. You know, you're never going to get that solve for why it's living. Or could you get it solved for y explicit? Yes, you could. What can we do to get it solved for y explicit? I don't know. No? You multiply the x or divide the x. Well, get rid of that cube by taking a cube root, right? Cube root both sides. So then you get x squared plus 2y squared equal to the cube root of c1x squared. Then you could subtract that x squared, and then divide by 2, and then take the square root of all that there. It's not pretty. It's not pretty. So we can just leave this alone. Y'all got the gist, though, of the substitution that you got to make. Now, much easier than these are the exact equations. Those are easier. Remember that an exact equation, what it is, it's the sum of the derivative, the partial derivatives for an original function. This x plus sine x dx, that means that was the partial derivative of my original function with respect to x. And this is the partial derivative of the original function with respect to y. So to solve this, you get to kind of work backwards. Remember that? Just kind of work in reverse. We call this first part m. I can't write. And the second part n. So the test for exactness says that the partial of m with respect to y should equal the partial of n with respect to x. Let's see if that's true. Partial derivative of m with respect to y would be cosine y. And that's it. Over on this side, n with respect to x, right here, x, the constant would be your derivative, so cosine y. Check. That works. Okay, so start out. What was my first step? Y'all tell me. This is the test time. What would we do first? Since those are derivatives, to work backwards, you're going to integrate them. Integrate one part. Any part you want to. So I'm going to take the first part. The integral of x plus sine y dx. Integrate that with respect to x, and I'll get x squared over 2 plus x sine of y. You'll just stick an x to it. Plus there was possibly what? Not a constant, but something that was just y's, right? Something possibly that was just in y variables, so I'll call it g of y. Now guys, guess what? In that first step, you have 3/4 of your answer. We've almost got the answer in just that one integration step. Okay? The only thing that I've got to find to finish my answer is this g of y. So let's say this is our potential, this is the possibility of our function here. That's the solution curve. So let's do the partial of that f with respect to y so we can compare it to this. This was a partial with respect to y for your original. So we got to do the partial with respect to y here and compare it to what we would get here. So if we do the derivative of this with respect to y, that would be nothing. On this one, it would be cosine y, that times x, plus the derivative of this function with respect to y would just be, we don't know what it was, but g prime of y, right? And you're comparing that to what you had over here, this x cosine y minus 2y. So according to that, what do we got? G prime of y would equal negative 2y. How do we work our way out of that? An integration step. So g of y then would be what? Negative 2y squared over 2, so negative y squared. Good job. Take that where? You can plug it in back right there. So my solution. This is a general solution. Would be 1/2 x squared plus x sine of y minus y squared equal to some arbitrary constant. Now, Zeb asked me this a while ago in the office. He said, how do you know how you check this? If this is your solution curve right here, if you take the derivative, the partial derivative of this with respect to x, you get what's in the first one. If you take the partial derivative of this with respect to y, you should get what's in the second one. On those, there's no reason you don't know 100% that you're right. Y'all should know when you turn your test in that you got that one correct. Could I still do an initial value on one of those? Could we do initial value problem yet? Sure could. You find C. You have to give it a point. If you keep plugging in for x and y, calculate your C value. Okay? All right. Then last week we started these linear ones. And I saved this one out just so we could have time to go over it. First order linear differential equations have a specific form that you want it to look like. You want the derivative with no coefficients. What happens if you have a coefficient in front of it? Divide through the whole equation by it. Clear it out. You want the coefficient to be 1. Right there. Your second term should have a y, or at least your dependent variable in there. In this case, it's r. Theta is your independent variable here. R is your dependent variable. R depends on whatever theta is. So in this case, the R represents your y that you normally see. Tangent of theta, theta is like x. Equal to some other function that should be just in terms of x, no y's involved in. No y squared, no other derivatives that have been raised to a power, anything like that. That makes it nonlinear. So these are first order linear equations. So we've got it in the correct form. What you need to do to calculate, to integrate, to solve these is use what we call an integrating factor, I of x. Who remembers how you find I of x? E to the integral of whatever's in the middle that's attached to the y. In this case, what's attached to the r, right? So the tangent of theta is what you're going to integrate. And y'all have got such wonderful cheat sheets out there that you should be able to tell me that pretty quickly here. The integral of tangent, I think I do. Yeah, I do know what it is, but you'll help me out. Negative natural log of cosine. U would just be theta here, right? Okay. Algebraticians and trigonometricians, help me figure out what that is. E to the negative ln cosine theta. Is it negative cosine theta? It's cosine of theta to the negative 1 power. He said it's 1 over cosine. That's right. What's in front of an ln? Whatever's been pulled out in front, it's an exponent. So what's in front of that ln? Negative 1. The power then becomes negative 1. This is cosine of theta to the negative 1, which Austin said was 1 over cosine. What is 1 over cosine? Secant theta. So my integrating factor this time is secant theta. Good. Okay. I'm asking y'all to remember a lot now, so who remembers what you do next? Multiply both sides by the integrating factor. Now, if you remember from last week's discussion, this is awesome because if you get the correct integrating factor, the left side is always the derivative of the product of the integrating factor and your dependent variable. So this has secant times r prime is what you would get. Secant times r prime on the left side. And on the right side, secant times secant is. So if I undo both sides by integration, what happens when you integrate something that's primed? The prime just goes away. Okay, cheat sheet time. Look that up. What's the integral of secant squared? Look it up. Be sure. It's just tangent. Tangent of theta plus c. Okay? Get your trig bridges on here. I got to solve that for what? You want r, okay? So what can I multiply through by to clear that secant out? Cosine. Multiply everything by cosine and the secant will go away. Y'all remember that? Secant times cosine are reciprocals. So this is going to be cosine theta, tangent theta, plus C1 cosine of theta. We're almost there. What's cosine times tangent? If it's a first order linear, the integrating factor is the way you do it. Now, I gave y'all one of those tonight for extra credit on the test, so it'll be worth 5 points if you do it right. Okay? Now, one little topic I want to cover tonight. 2 examples I'm going to do with it, and then we'll take our test. But what if your equation looks a whole lot like a linear equation, but it's not? And you know the test to tell whether it is or not. Bernoulli was scientist, mathematician. His Bernoulli brothers actually were involved in some of the physics stuff that you study. Very similar to a linear DE. Look at your form though. What's different? This looks like a linear equation. Derivative, you got your function from y to the first, that's what you're going to have there. But over here, you're going to have a power of y. Y to some power of that. That fits the perfect form for Bernoulli equation. Now we're going to do everything like linear, except we're going to do a substitution, just like what you know it, it's like on the unit, you got a substitution on it. What you do is, you're going to divide through by y to the n. You're going to divide everything by y to the n. You make the derivative over y to the n. When you divide y by y to the n, you'll get 1 over y to the n minus 1. And of course, you'll just do that with whatever your q of x is over there. We're going to take a new variable. I'm going to call it w. Instead of being w. W is going to equal 1 over y to the n minus 1. Whatever you got right here. Let that be your w. That will always work nicely because when you take the derivative of w, you're going to get what we get over here. Take the derivative, you get your w prime, you're going to have what we end up having over here. Which will make us have a nice little substitution in making our equation look linear. As you can probably guess, when you're going to finish out the linear method, when you get to the very end, if you have a w left in there, what are you going to replace it back with? What are you going to put back in the equation? Yeah, so it's just going to be a linear equation that's going to have a different substitution in with it. So let's try a couple of these. This is not in the correct form as is, so I'm going to try to see if I can't fix it first. I'm going to subtract that y over x. And to even separate it out a little bit better, I'm going to do this. That 1 over x will be my coefficient in front of my y. So the first step that you need to do there is divide through by y squared. that would give me 1 over y squared times y prime minus 1 over x times what? One over y. Good job. Good algebra. Equal to negative 1. So when we've got it in that form right there, remember I told you your substitution comes by whatever your new power of y is in your problem. So w is going to equal 1 over y, which we know is y to the minus 1, right? Something is y to the minus 1. So what would w prime be? Taking the derivative of y to the negative 1. Derivative. Negative 1 y to the negative 2, right? Somebody said that, negative 1 over y squared. Now, if you'll look, it's actually w prime would be negative 1 over y squared, y prime. Implicitly, y prime. Look at your substitution there, guys. This first term we got is 1 over y squared, y prime. So I can substitute in right here. What w prime for this whole term? What's the only difference? This one's negative, this one's not. We can say this is negative w prime. Okay, when I make that substitution. Now see the difference between this right here and this. Only difference is that minus sign. It should always happen that it should be almost identical at the same time. So we're going to say that we're going to resubstitute that equation with w's and say that that will be negative w prime minus 1 over x times w equal to negative 1. So you took this equation right here and wrote it in terms of w's instead. And of course you can't solve it with that one being negative, so let's change everything sign. W prime plus 1 over x times w equals positive 1. Now treat it like a linear equation. So we're going to solve this with an integrating factor. I of x is equal to e to the integral of 1 over x, which will be e to the ln x, which is what? Nope, just x. E to the ln x is just x. And there's nothing in front of the ln, so there's no power. Okay? No power, it's just x. So the integrating factor is x, so I'm going to multiply both sides by it. X times w prime plus 1 over x times w equals 1 times x. We know that this comes out on the left side to be x times w prime equal to x. Now what? Integrate both sides. So I get x times w. What's the integral of x? Plus constant. Okay, so what does w equal? Divide through by an x, right? I want to say x over 2 plus constant over 2. Well, I'm sorry, not constant over 2. Constant over what? X. sorry. If I divide through by x, that's what we would get. X over 2 plus the constant over x. Please endure to the end. Okay? What was W? 1 over y? Okay, I got an idea. See if y'all like my idea. Let's write it that as one fraction. What would my common denominator be? What would your common denominator be? 2x? So in the first fraction, I need x, so x squared. And I need 2, so the constant will just be constant. 2c, doesn't matter. So, make your substitution. W, y'all said was 1 over y. So what is y? Yep. There's the solution to my equation. Did y'all realize how that works? If you got 1 over y, that means the reciprocal of it. So y would equal the reciprocal of it. Okay. Pretty easy to switch that up. Okay, let's do one more Bernoulli equation. Questions on this one? Did I lose anybody real bad? It's the substitution part that's the hardest. It is the hardest part of it. You got a question, Austin? Last one I want to do. Okay. Tell me some things about it that would let you know that it's a Bernoulli equation. You got a power, you know it's not linear, right? You have y squared. So let's move that over. Let's move stuff around. X squared, dy over dx, minus my xy, I'm going to move that on over here, equal to negative y squared. What's the first thing I need to do before I can do anything else? You don't want that coefficient on that derivative. That's right. He said divide through by that x squared. So we're going to do that first. X over x squared will be 1 over x times y. And we'd have negative 1 over x squared and y squared there. Now what? Yeah. You could put the y over the x because in the linear form, you always wanted the y by itself right there in that term. That way I know everything else is the coefficient of it. Yeah. If you like that, you sure can. If it would help you, do that, keep things separated, situated. back to that previous example. What do we do next? You want to get rid of that y power, y squared. Divide through by y squared. So that would be 1 over y squared. I'm going to do what you said there, Austin, and put that as y prime instead of dy over dx. Same thing. Minus, if I do 1 over x, y over y squared would just give me 1 over y. And then leave me just the 1 over x squared over here on the right. Y'all doing good. Y'all, this is going to work out nice. Okay? So once you've got that, you know that this term right here is your substitution term. W equals 1 over y. So W prime, again, would be negative 1 over y squared y prime. So again, you got that negative difference. That's not negative right there. So I'm going to go ahead and change that. Negative W prime minus 1 over x times W equal to negative 1 over x squared. Integrating factor. E, this is different than the one we had a minute. No, it's not. I'm not. Duh, sorry. Y'all ain't keeping me on my toes here. What do I need to do? Let's get all that, we want that first term positive. Absolutely. Now I can have an integrating factor. E to the integral of 1 over x, which is going to be e to the ln x, which is x again. So x times w prime plus 1 over x times w equals 1 over x squared times x. Multiply both sides by the integrating factor. Okay? So that left side should always be x times w, or x times whatever your variable is, prime, equal to just 1 over x. Integrate both sides. We get x times w equal to, what's the integral of 1 over x? ln x plus c. Okay? I need some room to spread out here. Okay, now what? Why do I try to be, what a goofus. Okay, now what? I'll make it more complicated. W is equal to 1 over y. So what's y equal to? Okay. Y'all won't see old Bernoulli till next quiz, though. You don't have to worry about him for a while. We'll go back and review that as we need it.